Hi everyone, welcome back. Today we're talking about inverse of trigonometric functions. So we've actually already talked about finding inverses of trig functions, but these were for angles that were between 0 and 90. Specifically when we were looking at right triangles, we were able to solve for an unknown angle measure using the inverse of either sine, cosine, or tangent. But now we have to take a look at, well, what about, we know all the angles now. How do we find the inverse of any of the angles that we're looking for? So first off, I have on the left-hand side, we've got y equals sine of x. That's the graph of your sine function. And then remember how to find an inverse. You switch the x and the y values and then regraph it, right? So then over on the right-hand side, x equals sine of y is the inverse of y equals sine of x. And they're definitely related, right? You just have like the squiggle going vertical as opposed to horizontal. A few things that we need to point out is that y equals sine of x is definitely a function, right? It passes the vertical line test. But then over x equals sine of y is definitely not a function. It does not pass that vertical line test. And kind of that's sort of an issue when we go to find what angles have certain sine values. So a few more things that I want to point out is that where is each chunk of the graph matching up with each quadrant? So from 0 to pi over 2 is quadrant 1, right? So you see that over on the inverse function from 0 to pi over 2. So I labeled that as the first quadrant. And then the second quadrant comes from, or goes from pi over 2 to pi. And you see that over on the inverse from here all the way to here. I called that quadrant 2 for you. And you can continue this, and let's go orange, from pi to 3 pi over 2. You can see that over here, called it quadrant 3. And quadrant 4, let's go purple, is from 3 pi over 2 to 2 pi. And it just kind of keeps repeating itself. Now, what I need you to pay special attention is that if you've got quadrant 1, quadrant 2, quadrant 3, quadrant 4 is in purple over here, and quadrant 4 is up here. Now, which quadrant would be from 0 to negative pi over 2? Why did I label that as negative pi? Or negative 1 quadrant, sorry, negative pi. And that's technically the negative first quadrant from 0 to negative pi over 2 right here. So you see that piece of the graph from 0 to negative pi over 2. And then the negative second quadrant would be, I'm running out of colors here, negative pi over 2 to negative pi. So right here to here would be negative second quadrant. And keep going. Let's go brown from negative pi over 2 to negative 3 pi over 2. This would be your negative third quadrant and negative fourth in the end. And of course, it keeps going on, right? So we can label this negative third power, negative fourth power. Now, why did I stress negative first quadrant? It's because when we go and we restrict our domain of our sine function, we are actually defining our sine, or actually our principal values of sine, to be from the negative first quadrant all the way to our first quadrant. So from negative pi over 2 all the way to pi over 2 is the piece of the graph that they are sucking out. We're actually deleting the rest of the graph and using just these principal values right in here if you see a capital letter or called arc sine, which we'll get into later. So let me see. here's a little information. We must restrict the domain of our trig functions so that their inverses are actually functions. If you take a look on the right-hand graph, the whole graph is not a function, but the pink piece that I just highlighted from negative pi over 2 up until pi over 2, from the negative first quadrant to the first quadrant, is a function. So the values in these restricted domains are called the principal values. Capital letters, that's really important. When you see capital letters, we're talking about these principal values, are used to distinguish trigonometric functions with restricted domains from the usual trigonometric functions. So here's a broad overview. We'll get into cosine and tangent in a second, but y equals sine, so you see that capital letter of S, capital letter of C, and capital letter of T. That means that we just want one principal value for what we're looking for. So y equals sine of x is actually defined as y equals sine of x on the restricted domain of negative pi over 2 to pi over 2. And in other words, I made a comment, aka quadrant negative first all the way to the first quadrant. And then cosine we'll look at in a second. It is actually only defined, or the principal values are only defined from the first quadrant to the second quadrant. And our y equals capital tangent of x is defined from the negative first all the way to the first quadrant as well. But take a look, that's not or equal to, because we're going to have some asymptotes. All right, let's get into cosine and tangent, all right? Let me look at cosine here. I'll come back to that above. When you go and you graph cosine function, you've got y equals cosine of x on the left, and then you switch your x and your y values, and you get y equals the inverse of cosine on the right. And you'll see that, let's go back to our highlighted. We've got from 0 to pi over 2, that's your first quadrant. And that is seen right here. And then our second quadrant, so I'll label first quadrant. Oh, don't want that. First quadrant. Our second quadrant. Third quadrant. And fourth quadrant. And then our negative first, negative second, negative third, negative fourth quadrant. So second, third, and fourth up there, and then negative first, negative second, so on and so forth, dot, dot, dot. Oop. Dot, 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 right? All right, so let me highlight what is in each of the quadrants. So our second quadrant goes here, which is this piece of the graph after you swap the x and the y's. Our third quadrant from here to here, which occurs here. And last but not least, we'll go blue. Fourth quadrant comes from this piece here. So when you look at your inverse function for cosine, you notice that, yeah, okay, so it's not a function, right? But we need it to be. So where are we going to restrict the domain of our cosine values so that we get an inverse that is a function? So the easiest piece is actually from 0 all the way up to a y value of, let me highlight all that, pi. All right, so this is, like, by definition what our cosine domain restriction is, so that our inverse of cosine is a function from pi, first quadrant all the way to the second quadrant. And so here's a little bit of an application. So maybe it kind of makes sense in a way as we move forward. If I'm looking for capital inverse of root 2 over 2, what I'm actually asking you for is what angle has a cosine that is root 2 over 2. And down here, if I just had a little c, that would be asking you what angle has a cosine value of pi over 2, right? And you go, well, I know 45 degrees has a x value of root 2 over 2, which is my cosine value. I also have 315 has a x value of root 2 over 2. So you're like, okay, cool. I've got an angle of 45 degrees. I have an angle of 315 degrees, and really any angle that's coterminal with any of those two. So you could go call it also negative 45 degrees is another one, and really dot, dot, dot. It'll go on forever, right? Take a look. 45 degrees is in the first quadrant. Your 315 is technically in the fourth quadrant. Whoops, V. And negative 45 is actually coming from the negative first quadrant. Okay, now the second I make this a capital C, now I'm restricting the domain. I'm looking only for the angle that has a cosine value of root 2 over 2, but is from the first quadrant or negative first quadrant. Oops, or second quadrant, cosine. Okay, so you're like, well, which angle has a cosine of root 2 over 2? And I go and I pick strictly and only 45 degrees because the angle over in second quadrant has a cosine that's negative root 2 over 2. So that one answer would be your 45 degrees. We're going to practice a few more of those. Okay, so if that's a little fuzzy, hang in there. All right, let's talk about tangent. Tangent is a little funky because our tangent graph is funky. You have your vertical asymptotes at pi over 2 and negative pi over 2. You've got your first quadrant, your second quadrant, third quadrant values, and your fourth, and your negative first quadrant, negative second, negative third quadrant, and negative fourth over here. All right, when you go and you look for, switch your x and your y values and then replot your graph, you get the inverse tangent of x equals tangent of y, which in other words, y equals tangent inverse of x. So you see your inverse function, again, is not a function. So we're going to restrict the domain of our tangent function so that our inverse is a function. So take a look. You're like, well, which quadrants are we going to define the easiest little piece of our tangent, right? And in pink, I've highlighted it, and you'll notice your asymptotes. So your domain does not include those asymptotes. So the range values go from negative pi over 2 up until pi over 2, but not including those asymptotes. It's not defined there, all right? So you're picking your values in the first quadrant and the negative first quadrant. And this is a similar situation to your sine function where it is only defined on the first quadrant and then negative first quadrant. Now, a common question that people ask is, well, why is it the first quadrant and not the fourth quadrant? And my argument for that would be, okay, you're cool with the first quadrant, right? But your fourth quadrant, remember, is located. Here's your second quadrant values, third quadrant values. And your fourth quadrant, which I didn't even graph that piece of the graph, would be up here, right? So picking and choosing and defining your tangent inverse with like just your first quadrant chunk and your fourth quadrant chunk up here would be weird, okay? So they're picking the negative first quadrant for that definition. Okay, let's see. A few key points that you need to understand. They do call this two different things. So if you run into anything called arcsine or arccosine or arctangent, it's just talking about the inverse function. All right. you've got any of the expressions that I circled down there, y equals sine, capital sine of x, and y equals cosine of x, and y equals tangent of x, really just means inverse sine of y, inverse cosine of y. Remember that -1 stands for inverse. Okay, and same story with arctangent, arccosine, and arcsine. And again, capital letters there. Capital letters here, capital letters here. If they're lowercase, you're going to have more than one answer. All right, let's get into some examples to see if it's making sense for you. All right, example 1, you've got cosine of x is equal to 3/2, and you're actually trying to solve for what x value or what angle. I write it out. What angle x has a cosine value of square root of 3/2. That's really what we're looking for. But it's got a capital letter, so we're going to restrict our answer to the angle that is in the, which quadrant? For cosine, first quadrant up until the second quadrant. All right, and that's because you have a capital letter. So take a look at your unit circle. I plopped one in here so we can all be on the same wavelength. All right, so go find me the angles that have cosines or x values of square root of 3/2. And you're like, boom, here. Nothing in the second quadrant because that one's negative. Nothing in the third quadrant because that's negative. You do have another cosine of square root of 3/2 that's positive over in technically the first or the negative the fourth quadrant or negative first quadrant, depending on what angle you tell me. So which one do we pick? Do we pick this one or do we pick this one? And you go, well, I need to be defined in the first or the second quadrant. Okay, I don't care about this one. I pick the angle that is in the first quadrant. If the question asked me for cosine of x equals negative square root of 3/2, you would pick the angle of 150. But it's not, so we've got x is equal to, we are speaking, pay attention, right? They want the nearest degree, so we're going to go degree of 30 degrees. Moving on. So example 3, we're going to find the value right angle measures in radians. So we're speaking in radians here. Round to the nearest hundredth if needed. I'm, for the most part, not going to be rounding, so you can see all of my work. Question A, we're looking for arcsine of square root of 3/2. So now we're in the world of sine, so you want to be looking at your y values. So where do you find angles that have y values of square root of 3/2? And there's one, and there's one. So remember, because we've got capital, we're restricting our domain. And the domain restriction for your sine is in the first quadrant or negative first quadrant. Agreed? So because 2 pi over 3 here is in my second quadrant, he doesn't lie within that domain restriction. So I'm going to pick the angle of pi over 3 as my answer. Now, a little takeoff, look over to I added like a little extra example right in here, and you can see how things would change if I went arc sine of negative square root of 3. I would be asking you, what angle has a sine value of negative pi over 3, and I would go, well, negative pi over 3 is negative pi over 3, y value, and also a negative square root of 3 over 2. And you're like, okay, cool. This angle of 4 pi over 3 is in my third quadrant. The angle of 5 pi over 3 is actually lying in my fourth quadrant. But like we just talked about, our inverse is defined on the negative first to the first quadrant. So don't you put 5 pi over 3. That's an angle in the fourth quadrant. I want actually, the coterminal angle to the 5 pi over 3, but going in a backwards direction. So that would be a negative pi over 3 radians. So that's kind of an important concept. Watch out for that negative first quadrant. Now, in part B, we're actually going to shift gears just a smidge. And technically, this looks complicated, right? But here's your capital letter. I'm pointing it out because I didn't have it typed. Capital. Maybe I should make it more drastic. So capital cosine inverse of 6 over 7. Now you're like, I don't know, that's not on my unit circle, right? But I know cosine, let's sort of just draw an angle. We're looking for an angle. Now remember, cosine is defined on the first quadrant and second quadrant. So I'm starting like in the middle here. I'm going, what angle has a cosine value of 6 over 7? And my cosine value in the first quadrant is positive, and my cosine value in my second quadrant would have to be negative. So I'm actually going to place my angle, whatever angle it is, I don't actually know, who knows, over in the first quadrant. And then cosine is your adjacent side divided by your hypotenuse. Now hypotenuse will always be positive. So cosine, my adjacent side would be the 6, and my hypotenuse would be 7. So I technically have this angle. I don't really know what it is, but I have it. So now, can I find tangent of that angle? Of course, because you have a nice little right triangle here. You can do a little Pythagorean theorem and solve for that opposite side. So 6 squared plus, I'll call it x. X squared is equal to your hypotenuse squared. Solve that, you get x squared is equal to 49 minus 36, which is an x value of square root of 13. So once you solve that triangle, can you find tangent of that angle? Yeah. So tangent of theta would just be your opposite. Oops, some typos here. Hold on. Okay, so square root of 13 for your x. So tangent of that angle would be square root of 13 divided by your adjacent side of 6. And I mean, just so you can check your answers, you can round to the nearest 0.6. So a takeaway of that problem is, did we actually have to find the angle of theta? No. We used it along the way, but we didn't, I have no idea what theta is, but I do know what tangent of theta is. It's 0.6. So these problems are usually pretty hard for you guys. So I'm going to give you a couple more examples of this. You've got tangent of capital S, right? So our principal value of sine inverse of 1/2. All right, so take a look. Sine is defined where? In the first quadrant and in the negative first quadrant. So if I have a sine value of 1/2, which quadrant does that place me? Because sine is positive, I'm going to go and make my angle in the first quadrant. If it was sine inverse of -1/2, I would have a triangle in the negative first quadrant. So sine is your opposite, so opposite over your hypotenuse. So I'll label as my opposite side of 1, my hypotenuse is 2. We can solve for your adjacent side using Pythagorean theorem, or you might even just recognize that it's square root of 3. So now, can we find tangent of theta? Yeah, be the angle, and your opposite side would be 1 over square root of 3, and rationalize. So square root of 3 over 3. Again, I didn't actually have to find theta. So this is C and D are super close, right? So I'll show you what happens when I make that 1/2 negative and how that changes things. So remember, sine is defined on the first and the negative first quadrant. So you're going to put your triangle down in the negative first quadrant because I need a sine value of -1/2. So my angle's going down. All right, sine is your opposite over hypotenuse. So here's your theta. Label your opposite side as I'm going to give the negative to the down length, right? It's down in the negative first quadrant. So this side would have to be positive and this side of that triangle to be negative in order for it to be in that quadrant. And your hypotenuse is always positive. A little Pythagorean theorem, or recognize that it's square root of 3. And now a tangent of theta would just be your opposite, -1, over your adjacent, square root of 3. And rationalize, that would be negative square root of 3 over 3. So the signs matter here. Make sure you're checking your signs as you go. They can be little tricksters. Okay, what's sine inverse? What angle has a sine value of -2? In other words, you might run into this like we did before in law of sines, where you see sine of x is equal to -2, right? When you do sine inverse, what happens? You get x is equal to sine inverse of -2, and -2 is technically outside of the range of sine, so you get a domain error, aka there is no angle that has a sine value of -2, so does not exist. Okay, your -2 is outside of the range of sine. All right, back to a problem like we did sort of in the very beginning. I just threw in an extra one. Oh, I don't want to give that away. So we've got, what's the principal value of cosine inverse of -1/2? Okay, you look for your cosine. Cosine's all your x values. Which ones have cosine values of -1/2? -1/2. So these two angles are what you're going to pick from. And we're speaking in radians, let me remind you. So which one do we pick? Now, cosine inverse is defined on the first quadrant and the second quadrant. So you're going to pick the angle that's in the second quadrant. So your answer is just, in radians, 2 pi over 3. And that pretty much wraps up that lesson. I hope you guys have a wonderful week.